Well, this is a class activity. Thought I would give you something to try on your own now, okay? So you could just try and work this one for yourself, and then you could check to see if we get the same answer, okay? I'm going to go through it, but right now you could just pause the video a bit, try, and then see what both of us arrive at. All right, cool. Now let's get into it. As we have stated, since y is equal to some expression in x and also in equation 1, and let me state it there. So this is equation 1. And also in equation 2, y is equal to some expression in x. Okay? So basically what I could say, I make my statement, equate. I'm going to equate equations 1 and 2. Now equation 1, and I tend to have the habit of writing the equation in y that has the quadratic first. So what I'm going to do here, I'm going to say x squared plus 4x minus 3, and that is equal to, and then I'm going to write this, the equation 1 now, which is 5x plus 3. Now, as we have stated, we want to bring everything on the right side to the left side so that 0 is left here. So I'm going to say x squared plus 4x, but when I look, I have a term in x here, so I would want to group them. So this is positive, so I must subtract to bring it over, minus 3, and that is equal to, and this is 5x, but remember we had to subtract 5x to bring it over, so we have to do it to this side also, minus 5x plus 3, and here I'm left with x squared plus, oh oops, it's not plus, we have a positive 4x and a negative 5x, so that will leave us with a negative x minus 3, and that is equal to, this 5x will cancel out with that 5x, so I'm left with plus 3 over here. So I have a positive 3. Now I need to take over my positive 3 to this side, so that 0 is left over here. So here now I would have a x squared minus x minus 3, and since this is positive, to bring it over, I would have to subtract 3 from both sides of my equation. So I would have this 3, and I'm subtracting 3 now. So I know that a positive 3 and a negative 3 would cancel out. So basically what I'm left with is x squared minus x. And minus 3 would give us a negative 6. Remember, when the signs are the same on the numbers, you add the digits and keep your sign. Okay, so I would have a negative 6. 3 plus 3, 6. Both numbers were negative, hence I have a negative. And that is equal to 3 minus 3 would leave us with a 0. So now we have a quadratic equation in its general form. Now, in the previous video, I looked at solving a quadratic by using factorization. In this video, just to show you that it doesn't matter which type of method you use, it still works. I'm going to use the quadratic formula rather to solve. So I'm going to just identify what is a, and if you notice, the coefficient a is the coefficient of x squared, and the coefficient of x squared is here is 1, and also it's the coefficient of x there is 1, and my constant is negative 6. So a is equal to 1, b is equal to negative 1, and my c is equal to, and c is equal to negative 6. So really what I have here in my quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over, and remember, as all over 2a. Now what I have here, I'm just going to substitute what is a, b, and c in the respective equation. So just let me pull up my screen here a bit. Let me just take it up there for a bit. So we have x, and let me change my color. So here we would have x is equal to negative, and what is b? B is negative 1. So I'm going to take out b, put in negative 1, close my bracket, plus or minus the square root, and b is negative 1, so I would have that's negative 1 all squared, minus 4, and a is 1 multiplied by 1 times c, and we know that c is negative 6. And I'm going to close my bracket. Just let me extend this a bit. So I have, this is all over 2 times a, so I would have 2 over 2 times 1 rather. Good. So let me just take this up here a little, just for to have the space to work with. So what I'm left with here, guys, I am just going to simplify this to say now that x, let me just change the color. So I would say here that x is equal to, look down here, right here, I have a negative sign in front of this bracket, so it simply means I want the opposite of what is inside the bracket, which is the opposite of negative 1 is a positive 1. So I would have x is equal to 1 plus or minus the square root of negative 1 squared, which would give me a positive 1, and I have a minus 4 times it, times 1 would give me a minus 4, and minus 4 times negative 6 would give me a positive 24. And that is all over 2a, and a is 1, so I would have 2 times 1 is 2. So here I would say x is equal to 1 plus or minus the square root of 1 plus 4, 24 rather, is 25, and that is all over 2. So really x is equal to I have a 1 plus or minus the square root of 25 is 5, and that is all over 2. That's all over 2. Okay, so here now, as we have stated when we were solving quadratic equations by using the quadratic formula, we had stated that when we reach here now, all we're simply going to do is to split the plus or minus sign. So here I would have, and just let me change the color just to indicate, I would have x is equal to 1 plus 5, and that is all over 2, and then I would have or x, and let me change the color again, let me change it to a green. I would have a x, no, that is too dull, sorry about that, guys. Yes, that's good. And now I would have a x is equal to 1 minus 5, and that is all over 2. So what I did here was to just share the plus or minus sign. Here I said 1 plus 5 all over 2, and here over here I said 1 minus 5 all over 2. So in this case here we would have x is equal to 1 minus 5, I would have a negative 4 over 2, and that would be equal to, we know that a negative divided by a positive will give me a negative, and 4 divided by 2 is basically 2. And also over this side I would get 1 plus 5, that would say x is equal to 6 all over 2, and we know that 6 divided by 2, that will give us a solution of x is equal to 3. Now we have found our two solutions in x. Now we need to find our two solutions in y. So again, it's pretty straightforward from here. I am just simply going to take my first x value here. X was 3, found x to be 3, so I'm going to say substitute x is equal to 3 into equation, and I'm going to choose the simplest equation, and the simplest equation would be equation 1 in this case, into equation 1. So equation 1 states that y is equal to 5x plus 3 So I'm saying y is equal to 5 times, and x is 3. So when x is 3, I want to find that corresponding y value. So y is equal to 5 times 3 is 5 threes 15 plus 3. So y would be equal to 18. So when x is 3, I have found my corresponding y value to be 18. So now I need to find also what is my corresponding y value when x is equal to negative 2. So I'm going to state again, substitute x is equal to negative 2 into, and I'm going to put it into equation 1 also, into equation 1. Okay, same equation, it doesn't matter. So equation 1 states again that y is equal to 5x plus 3. So I'm going to say y is equal to 5 times negative 2 plus 3. Hence, y is equal to 5 times negative 2, I would get a negative 10. A positive times a negative will give us a negative plus 3. So therefore, y is equal to negative 7. Okay, guys? Now, basically, from here now, I need to state my solutions. Okay, guys? So I need to say now, when x is equal to 3, my corresponding y value is equal to 18. And when x, let me just change the color. When x is equal to negative 2, my corresponding y value is equal to negative 7. And those are our answers. It's really that easy. Okay, guys, if you have any questions, feel free to post them, or any comments, or if you want to rate the video, you can freely go ahead. Okay, and if there are any questions, we'll get back to you as soon as possible. It's really that cool. The next thing I would like to state is that always, when you get your solutions, just always check yourself to see if you got your solutions are correct. So you could just go ahead and plug in, and I would recommend that you do it in both equations. Just substitute your corresponding x and y value inside both equations to see if it works out to be the same. Okay, guys, bye bye.